So what are the five main branches of chemistry? Well, it's an interesting question because people will like to argue about what actually is its own field and what is not. So from my knowledge, this video will be about my knowledge in the five main branches that I know of. And if you hear of like a different field, it most likely, if not definitely, is a subfield in one of these five main branches. So what are the five main branches? Well, first I want to talk about organic chemistry. Organic chemistry is the study of carbon and hydrogen. It's a class that's used to weed out med students. And this is because, med students are like, well, why do I need to learn chemistry? Well, you don't. It's to weed you out. The reason why it's a weed out class is because it teaches you study strategies and whatnot. So in the class itself, it teaches you to not do the quote unquote dump and flush after an exam. Everything in organic chemistry builds off of itself. So whenever you take the class, or if you are somebody watching this who might take organic, just know that everything builds off of the topics taught in the class. Nothing ever goes away forever. Well, I shouldn't say that. Very few things will go away forever. So just bear that in mind. And it teaches the pre-meds that they have to study very hard and not forget everything that they've studied after they've taken an exam. And oh, by the way, it's also a 2-semester class, which means that the stuff from the first semester you cannot forget for the second semester. Now, the field of organic chemistry is a field that's based on fuel, nutrition, polymers, and like other kinds of chemicals like pesticides and whatnot. You'll also talk about things like pheromones and like those kinds of compounds. Then, interestingly enough, a subfield of organic chemistry became so big that it's actually considered a main branch now. So in that category, we have biochemistry. Biochemistry is the study of life processes, and it's a class where you get to talk about molecules like proteins, lipids, DNA, and medicine. And it became its own field in the 1950s, I believe, once we were able to figure out the structure of DNA. And it started out small, of course, but it became so big that it's actually its own branch now, but technically it's a subfield of organic. Then we have analytical chemistry. Analytical chemistry is a class on lab techniques. And it basically is a class of you have some sort of sample, figure out what is in that sample. A great example would be testing lead ion concentration in water, because it's important that the lead concentration isn't so bad to where people start having health problems. So you need analytical chemists to come in, take some samples of water, and take them back to the lab to process them. That's the field of analytical. They also test out different kinds of over-the-counter drugs, or even not over-the-counter drugs, to figure out what compounds are in that pill, and see if the reported concentration on the bottle matches the concentration of the pill itself. And it's one of the most useful classes to take as a pre-professional major, or somebody who might end up working in a lab like a biology major. So yeah, that's analytical. Then we have inorganic. Inorganic is the study of every element that's on the periodic table that is not carbon and hydrogen. In this class, you learn about the periodic table, such as like the different groups, like the properties of the different groups on the periodic table. So like the properties of group 1, the properties of group 2, group 15, group 16, and then you talk about transition metals, why they're called transition metals, and stuff like that. You also talk about something called a coordination compound, which introduces you to the concept of a ligand, which is essentially, it's just a Lewis base really, but it's where it has like a metal center, so a transition metal as its center, and then depending on what kind of, like the geometry of the compound determines how many ligands is attached to that metal center. If you don't know what that means, don't worry about it. Coordination compounds are not bad. It's just a different way of looking at certain compounds in our universe. And it's essentially Gen Chem 3, which just means that it's a continuation of Gen Chem 2. And then finally, the fifth branch, main branch of chemistry, is called physical chemistry. Physical chemistry is the physics of chemistry, and it's where you talk about thermodynamics and quantum mechanics. If you know anything about physics, it's essentially the equivalent of thermal and statistical mechanics and quantum mechanics. So two classes in one, essentially. So the first semester of PChem is the thermo portion, which is thermal and statistical, and the second half of the semester, or excuse me, the second half of the year, which is second semester, is quantum mechanics. Depending on what university you go to, you could actually take the quantum part first and then the thermo part. I guess it doesn't really matter, but most of the time it will be the thermo part first and then quantum. Every other field that's out there essentially falls into one of these 5 main branches. Okay, so I've seen people try to argue that nuclear chemistry is its own field. Well, no, not really, because nuclear chemistry is the study of essentially nuclear reactions, which is the study of compounds that are not carbon and hydrogen, which means it falls into inorganic. And actually, in inorganic, we did some of the nuclear reaction chemistry, which is called radiochemistry. Then there's one more interesting field of chemistry that is becoming way, way, way more prominent than it was even 30 years ago, which is called the chemistry and physics of solids. So it's solid state chemistry. And this subfield of chemistry actually sits at the boundaries of all of these chemistries. More so inorganic, physical, and a little bit of organic. It really lies at the boundaries of those 3. But it will become its main branch in some time in the future. Maybe if it gets that big, it will. But I know that that's the big field right now. All the companies are just pouring money into solid state chemistry. And to study solid state, you need to know all your chemistries, which is kind of why it lies at the boundaries. But yeah. Anyway, that's all I wanted to say. So I hope this helped.